In this exercise, they're asking us to measure the thermal expansion of two different materials. There's super Invar, which is a really cool material with a very low coefficient of thermal expansion. And we want to compare with the same table made of steel. All right, so first of all, we want to know how much the table will expand if the temperature increases by 6 degrees. So our delta T here is 6 degrees. And what we want to know is how much will the table expand? That is delta L. So this equation here is what we need to use. In this equation, we have alpha, which is the coefficient of thermal expansion and is different for different materials. Super Invar has a very low alpha compared to other materials like steel. And then L0 is the length of the material that we are considering. In this problem, L0 is going to be equal to 1.8 meters. Because that's the length of the table, which is shrinking and expanding depending on the temperature. All right. In the problem, we have alpha. It is given for Invar, and it is 0.2 times 10 to the minus 6 Celsius minus 1. Those are the units of alpha. And for steel, so I'm going to write Invar here because this is only for Invar. Alpha for steel is different. It is 12 times 10 to the minus 6. And same units. So let's compare. Delta L for Invar is equal to alpha times L0 times delta T and when we do the multiplication, we obtain 2.16 micrometers. A micrometer is 10 to the minus 6 meters. And then for steel, well, we will be using the same equation. So this first one was for Invar because we used the coefficient of Invar. Now this one will be for steel, and so we will use the alpha coefficient of steel, which is 12 times 10 to the minus 6 degrees Celsius minus 1. And same table, or same length of table, and same temperature change. So here is the same. We only change the alpha number. And what we obtain is 129.6 micrometers again. So So this is a lot more. And in fact, if we do the ratio between 2.16 and 129.6, what we find is that this is close to 160. 1/60, I mean. Which means that steel will expand 60 times more than Invar, which makes us realize how important Invar could be for very sensitive measurements like the ones described in the problems.